Good afternoon. Welcome to the live class on similar triangles. You know that similar triangle is a part of geometry and it is the 8th chapter. Generally it comes in the paper 2. You know that from chapter 1 to chapter 7 is the first paper and chapter 8 to chapter 14 is the second paper in general in SSC examination. As per the blueprint of examination, at least 11 to 14 marks will comes from this chapter. So you can understand the importance of this chapter. Who are good and who are perfect in this particular chapter, definitely they will pass in the examination. Who want to score maximum 10 points in their examination, also this chapter is very important. At the same time, so don't see in point of marks, in concept also very interesting, because this chapter has two theorems. One is a basic proportionality theorem called as Thales theorem, and the second one is the Pythagoras theorem. Based on these important theorems, some more theorems and riders also given in the textbook, and the teacher has to improvise the concepts, because you know that in the present CCA system no question will be given from the textbook. The questions are constructed based on the academic standards, which you know already: problem solving, reasoning and proof, communication, connections, and representation and visualization. Okay. At the same time, this the concept was developed by actually our Indian mathematicians. Okay, Aryabhatta, Bhaskaracharya, Varahamihira, and other mathematicians also contributed their services in the development of this geometry. So very interesting, very simple, and every children can understand it, but the teacher plays a vital role in giving concepts to them. That's the most important. So here in the chapter of similar triangles, we are clearly given it's a similar triangles. So everyone can understand. You have to know the flow chart of this similar triangles. First we will start with the flow chart, what you are going to learn, or you call it as a concept mapping or a mind mapping, whatever it may be the name, so you can follow it. So let's see what's given in the textbook, then we will discuss the concepts one by one. Clear? The first one, you know that simply we call it as similarity. This is a very important. Then it extends to similar triangles. Okay. In similar triangles, this is classified as a criterion. Criterion means what are the axioms or theorems support for the similarity of triangles, and the second one theorems, and third one is axioms, and the fourth one is riders. Okay. After that, in theorems we have two theorems actually specific to textbook I am giving, otherwise you have so many theorems here. One is called simply BPT, basic proportionality theorem, and the next one is a Pythagoras theorem. Okay. And we have one more in this, we have the, based on this we have constructions. This is a simple flow chart for the given textbook. So one is the similarity. In this chapter you are going to learn so which triangles are said to be similar triangles, and what is the criterion for the similar triangles, they are said to be criterion. And the next one, some theorems based on the similar triangles, and axioms, already proved statements, or some theorems also comes under this. And the last one, based on all these some problems are given in the textbook, those are, we call it as the riders. And the theorems are basically basic proportionality theorem, we name it as a Thales theorem, and the other one is call it as a Pythagoras theorem. So in the Pythagoras theorem you have some applications of Pythagoras is there, and basic proportionality theorem applications also is there. Then last one is a construction. So as you know that, maybe your teachers, all of you know that, so expected questions in 4 marks is definitely one construction will come. I am saying definitely means here by observing from 2015 March onwards the nature of the question paper. Clear? Because representation and visualization has 4 marks. At least 10% of marks will be given to this academic standard. Definitely the question comes under this academic standard. Clear? And one more, we have a long answer type questions also based on basic proportionality theorem, and Pythagoras theorem, a 4 marks question will come. So as a problem solving or reasoning and proof. So you have 4 and 4 means 8 marks will come from this 4 marks area, and 2 marks questions also possible from this area. So that's a very important. So application of these 2 theorems will comes under the 2 marks theorem for 2 marks simply, and 1 mark questions also possible. So at least 1-2 questions are 2 marks questions, and at least 2 to 3 questions from the this similar triangles. So finally 8 plus 4 12 plus 2, which is 14. I know that 14 is a pass mark. So children is very important. At the same time, teacher also has to take importance of this chapter. Don't get any hurry and worry to complete the syllabus. Completion of syllabus is important. At the same time, you have to give the conceptual clarity to the children. That's the most important. Okay, now we'll discuss that one by one. The first one is a similarity. What is meant by similarity? You know that. What is a similarity? Here there is a small confusion in the minds of the teachers as well as the children also. Similar and congruent, these are the 2 words. Okay, so what is similar and what is congruent? So for this, the 2 words are very important. One is called size and the second one is called shape. Okay, size and shape. If the triangles or the figures, any plane geometrical figures have the same shape only, then we call it as those are similar figures. They have same size and shape also, then we will call it as those are congruent. This is a very important. So you have to understand the difference. When they have same shape, then we call it as similar. When they have same size and shape, we will call it as congruent. From this you can get a relation. Can you say what is a relation? Anyone, can you say what is a relation here? All congruent figures are similar figures, but all similar figures need not to be congruent. This is most important. Okay. For example, the circles of different radii are similar. 2 centimeters radius circle, 5 centimeters radius circle, 8 centimeters radius circle, those are similar. Are all right angle triangles are similar. All equilateral triangles are similar, because the shape is same. But when you take triangles, there are so many kinds of triangles. We can classify the triangles as per size, of course, means size of the side, and as for the measure of angle also. As per size of the side, of course, measure of the length of the side, we can classify the triangles as equilateral triangles, isosceles triangles, and scalene triangles. With respect to angles, we can classify it as a right angle triangle, acute angle triangle, and obtuse angle triangle. Is it clear? So all these are different triangles. No right angle triangle is an equilateral triangle, and no equilateral triangle is a right angle triangle. So their shapes are not equal, not same. So obviously those are not similar. Okay. So are you understand the difference of that is called similarity. What is meant by similarity? If the geometrical figures have the same shape with the different sizes. Here shape is very important, and sizes will be maybe equal, maybe differ. So those is that property is called simply similarity. Okay, now come after getting the clarity about the similarity. Now there is a relation, already I said all congruent figures are similar figures, but all similar figures need not to be congruent figures. Clear? Okay. Now coming to the specification. So instead of taking the whole as a similarities, so we will take a similarity for the triangles. Okay. Now I am taking a triangle, you know that. This is one triangle, say this is another triangle, say triangle ABC and triangle DEF. I am drawing 2 triangles here. If angle A equal to angle D, angle B equal to angle E, angle C is equal to angle F. Okay. So, means A is D, angle A equal to angle D, angle B equal to angle E, angle C is equal to angle F. Means all the three angles of one triangle are equal to the corresponding angles of the other triangle, then those two triangles are same shape. When they have same shape, then what we call it as? Those are similar triangles. So, this is call it as A angle, this is angle, this is angle, angle. But we are not using that angle axiom of similarity. We are saying it is angle axiom of similarity, but not angle 3A's. Can you imagine it? What is the reason for it? This angle equal to this angle, this angle equal to this angle. You know that angle sum property. What is angle sum property? Sum of three angles of a triangle is 180. When the sum of three angles equal to 180, means two angles are equal, third angle should be equal, correct? So, no need to say, that is the reason we will say angle axiom of similarity. This is the most important. After observing the similar triangles, we have some more, another one is called it as, if you take it as all these, we have generally call it as the corresponding sides, like it as AB and DE, AB by DE is equal to AC by DF, which is equal to BC by EF. Means all the three sides of one triangle are in proportion to the corresponding sides of the other triangle, then simply the two triangles also similar. So, here side axiom of similarity. This is called side axiom of similarity. Okay. Now, I am changing one more, means here this angle equal to this angle, means I am taking another possibility of that, that is AB by DE, this and this is equal to AC by DF, and angle A is equal to angle D. Means corresponding sides are in proportion and included angles are equal. Means this is called, this is S, this is S, this is angle. Side angle side axiom of similarity. Okay. So, like you have the criterion for the similarity of triangles. So, this is the most important. Here, do not by heart it. My sincere advice to all of the children and my sincere advice to all the teachers say, do not ask them to write 5 times, write 10 times or by heart these statements, it is not correct. That error is eradicated. So, children has to understand, because the same concept will come in the examination, but the same figure, the same letter, the same formula will not come in the exam. Same writers will not come in the examination. No question will be repeated in the examination. So, definitely, so the children if understand the concept, then only you can write the question. So, ask them to understand, then okay. Here give an activity to the children, actually give an activity to the children, construct two similar triangles. Okay, ask them to take two right angle triangles, draw two right angle triangles and just compare. So, when you change angles, sides, like, so what are the criterion you have to obtain for the similarity of triangles? Ask them to find out. Clear? That is a very, very important. Okay, now coming to the theorems based on this statement, of course, one is call it as a basic proportionality theorem, BPT. Okay. So, BPT means here, sir, all it is called Thales theorem. ABC is the triangle. So, when you take ABC is the triangle, when you draw a line, say DE, okay, when DE is parallel to BC. So, here DE is parallel to BC, then AD by DB is equal to AE by AC. AD by DB is equal to AE by EC. This is actually a symbolical representation of basic proportionality theorem, or if you want to say in statement, in a triangle the line drawn parallel to one side divides the remaining two sides in proportion. So that is called a basic proportion. From this you can using a dividend component and dividend like different by adding 1 to this. AD by DB plus 1 is equal to AE by EC plus 1. Of course, AE by EC plus 1. Then it is called AD plus DB by DB is equal to AE plus EC by EC. Of course, AD plus DB is AB. AD plus DB is equal to AB by DB, which is equal to AE plus EC is AC by EC. You can use it for next one. Otherwise, if you take it as a reciprocal of this one, means DB by AD is equal to EC by AE. When you add it, then you will get another one. So you can say another one is AD by AB is equal to AE by EC. You can prove it also. The reason is triangle ADE, this one, is similar to triangle ABC, correct? Because this angle equal to this angle, corresponding angle, this line is parallel, this angle is equal to this angle, those are corresponding angles. So triangle ADE is similar to triangle ABC. Then AD by AB is equal to AE by EC equal to DE by BC. This is very important. Here the most important thing for the similarity of triangles is naming of the triangle is very important. Naming of the triangle AD is similar to triangle ABC, this is correct. So triangle ADE is similar to triangle ACB, this is wrong. Okay, so how you say this wrong means here triangle AD is similar to triangle ABC means here A equal to A, D equal to B and E equal to C. Like you have to say exactly which are corresponding angles and which are equal also. So naming of the triangle is very important for the similarity of triangles. So take care in doing this. Clear? This is called basic proportionality theorem. Of course, when the corresponding sides are in proportion, then those two triangles are in similar. So like also you can say it. So the converse of BPT. Advance of this theorem is also very important. In the textbook, in the exercises we gave this questions, that is called the midpoint theorem. Actually midpoint theorem is not given as a theorem in the textbook. In the exercises we gave the midpoint theorem, it is very clear. So when you take it as in triangle ABC, D is the midpoint. So when D is the midpoint and E is the midpoint for AC, when you join these two, the line segment which joins the midpoints of any two sides of a triangle is parallel to the third side and half of its length, means DE is parallel to BC and DE is equal to half BC. Okay, this is the one. And we have one more, means the converse of this theorem. Converse of this theorem means if you take it as ABC, so D is the midpoint and the line drawn parallel to the second side, it bisects the third side. That is the theorem also. In a triangle, the line drawn from the midpoint of one side parallel to the second side divides the third side in equal, okay, or bisects the third side. So these two theorems are also useful. So in the application of it, is it clear? Okay, now coming to the next one. Sometimes you have to use it by using the similar vertical angle bisector theorem. So ABC is a triangle. Okay, when you take it as a so A is a vertical angles, and for example D is a angle bisector, then you can say BD by DC is equal to BA by AC. Okay, so it's a vertical angle bisector theorem. This is a most important. Clear? Okay. So, these are the some theorems based on basic proportionality theorem. You have to practice it. The very important note is no theorem will be given in the examination, it is clear. So, do not by heart the proof of the basic proportionality theorem, there is complete it is a useless. So, just understand what is basic proportionality theorem, what are the theorems are derived based on basic proportionality theorem, that is the most important. Now, coming to the next one is a Pythagoras theorem. So, you know that this is the most important theorem, that is Pythagoras theorem. If you take it as ABC is the triangle, and you know that when you take a triangle ABC and B is a right angle, the square of the hypotenuse is equal to sum of squares of remaining two sides. Means simply you can say AC square is equal to AB square plus BC square. So, AC square is equal to AB square plus BC square. This is the most important. When you take a triangle ABC, so the square of the hypotenuse is equal to sum of squares of remaining two sides. This is called Pythagoras theorem. You know that one of the chapter in your textbook trigonometry totally based on this Pythagoras theorem. In number system also we have excellent application of this Pythagoras theorem. You call it as Pythagorean triplets. 3, 4, 5 is a Pythagorean triplet. 3 square 9, 4 square 16, 5 square 25, 9 plus 16 25, which is 5 square. So, like you say 5, 12, 13, 6, 8, 10. Okay, like you can say so many Pythagorean triplets, and there is excellency in the Pythagorean triplet. So, at least one number of a Pythagorean triplet should be even number. Maybe all are even numbers. Without even number, there is no Pythagorean triplet. If all are prime, it is not a Pythagorean. Just it is a triplet, it is not a Pythagorean triplet. It is a very important. You have to understand that. Okay. So, this is a Pythagoras theorem. Based on Pythagoras theorem, you have so many theorems on this based on that. So, now we will check it one by one, very important. So, before going to practice the different riders, I will give some more other property. When two triangles are similar, for example, the triangle ABC and triangle DEF, these two are similar, those are similar, will be represented like. When the two triangles are similar, just draw the triangles also, for example, ABC and say DEF. Okay. So, here when you take the areas of triangle ABC by area of triangle DEF, the ratio of areas of similar triangles is equal to the ratio of area of similar area of triangle ABC by area of triangle DEF is equal to, you can take any one, because AB and DE, for example, A equal to D and B equal to E and C equal to F. If you say that the corresponding, so C and F are equivalent also, those opposite sides are corresponding. So, AB and DE. So, AB by DE, AB square by DE square simply. Area of triangle ABC by area of triangle DEF is equal to AB square by DE square, or you can say AC square by DF square, or you can say BC square by EF square, like you can say. Definite, very important statement. By based on this, so many questions will come in the exam. So, this is one of the important property also. When the two triangles are similar, so definitely the ratio of areas of similar triangles is equal to the ratio of squares of corresponding sides, like the ratio of the medians drawn to the corresponding sides also in the ratio of areas of triangle ABC and area of triangle A. The most important one is ratio of areas of similar area of triangle ABC by area of triangle DEF is equal to perimeter of triangle ABC by perimeter of triangle DEF. Perimeter of triangle ABC by perimeter of triangle DEF. For example, if the one, this is a one median, say this one you call it as AP and this one is DQ. then this one you can say is AP by DQ also, where AP and DQ are the medians for the corresponding sides, means BC and EF, like we can give it. There may be a myth in the minds of the teachers also, sir, all these things are not given in the textbook, so definitely the questions will not come in the examinations. It's already, I say, it's a myth. So your textbook will not give the total concepts in the present textbook, because there is some conditions for writing a textbook. So we can't dump all the things in the present textbook. So we will give the information, and this textbook is meant for the children, not for the teacher. The teacher has to develop the concepts from the different resources. He has to explain the things to the children. This is the most important. So as what given in the textbook, it is meant for the children, and the teacher has to develop the things in the classroom transaction. This is the most important. Okay, so I will explain all the questions which are given as a worked examples, exercise questions, optional exercise questions. Okay, and rest of the things means do this, try this, and think and discuss questions. So my job is over. So my children will get 10 out of 10. Each children will pass in the examination. It's absolutely wrong. So they have to explain all these things. Okay, but this is not sufficient. We have to say different kinds of questions. They ask you to practice the maximum number of questions, then only the children can get the conceptual clarity. Okay, so now I will start with one problem, just to see the problem here, and very simple. Now based on BPT, first one is a triangle ABC. This is a triangle. So three lines are drawn parallel to three sides. This line is parallel to this line, and this line is parallel to this line, and this line is parallel to this line. Okay, through a interior point P. Then it divides into various parts, correct? Okay. The areas of the smaller triangle which are formed in the triangle are, one is 4 square units, second one is 9, third one is 16. Then find the area of triangle ABC. This is the question. So why I said this question to you means, here maybe all of you know that the teachers who are working teachers, they know that some of the what you call it as contract residence teachers, CRTs will be there, some are part-time teachers will be there. So maybe this question is an excellent question to you. So that's the reason I am saying this question also given in the NTSC examination also, National Talent Search examination also. Maybe all of you know that NTSC examination is going to be conducted in the first Sunday of November also, correct? So you have to understand that the concept is very important. So now you are going to find the area of triangle ABC. Here the required one is, what is the area of triangle ABC? So how to get the answer for this question? You can get the answer if you know the concept, you will get the answer by only one step. Otherwise it takes some more steps. Okay. So here the very important thing is, my simple instruction to all of you, when the question was given in as a diagrammatic, if the children copies the same diagram into the answer sheet, then we have to give its off mark for the children, which is the data for that. They are very, very important. Just go through the principles of evaluation, which is supplied by the SSC board. For writing data, we have to award off mark for it. So that's very important. Clear? Okay, so here what you are going to find the total area. So which concept will get that? This is a very important for geometry. You have to identify which concept, which property is very important. So you know that a criterion for the similarity or basic proportionality theorem or Pythagoras theorem or properties of similar triangles. These are the few concepts which are given in the textbook. Among these concepts, which concept is suitable to do that? So I am explaining a concept of similar triangles. Obviously you can understand, so similar triangles concept will come. Am I correct? Okay. So see, I am naming this triangle as this is T1, this one is T2, and this is T3. For our convenience, I am saying T1, T2, T3. Okay. So it's very clear, triangle T1 is similar to triangle T2, which is similar to triangle T3, and which is similar to triangle ABC. Am I correct? How those three triangles or four triangles are similar? Can you assume it? This angle equal to this angle, correct? these two are parallel, so corresponding. This angle equal to this angle, vertically opposite angles. This angle equal to this angle, means they are opposite angles of the parallelogram. So this angle equal to this angle, angle 1 equal to angle 1, this is angle 2 equal to angle 1 equal to angle 2, I said this is angle 3 equal to angle 4 equal to angle 5. So angle 1 equal to angle 2 and angle 3 equal to angle 5. The base angles are equal. So obviously the vertical angle also equal, so those two triangles are similar. When triangle T1 is similar to triangle ABC, like you can prove that triangle T2 is similar to triangle ABC, triangle T3 is similar to triangle ABC. Okay. Now come to the same one. So when you come to the total, I am taking the one of the property of the similar triangles, that is the ratio of areas of similar triangles is equal to the ratio of squares of corresponding sides. Why I have taken this property? Can you assume it? Because the areas are given. When the areas are given, you have the concern property is the ratio of areas of similar triangles is equal to the squares of corresponding sides, correct, ratio of corresponding sides. Now come to this one, triangle T1. So I am taking this area of triangle T1 by area of triangle ABC is equal to, what are the corresponding sides? No, I am taking the bases as, say this is B1, this one is B2 and this one is B3. When you say this is B1, this is also B1, am I correct? Because it is a parallelogram. When it is B2, this is also B2. Now the base of the bigger triangle is split into three line segments, B1, B2, B3. So we can come to a conclusion, B is equal to B1 plus B2 plus B3, correct? Okay. So area of triangle T1 by area of triangle ABC is equal to, what is the ratio here? B1 square, this is the base, and the total is, we will say it as B, B1 square by B square, or you can write it as simply square root of area of triangle T1 by square root of area of triangle ABC is equal to B1 by B, correct? Okay. Now for our convenience, I am just erasing all these things for our convenience. So I am taking the total. Are you understand? Square root of area of triangle T1 by area of square root of area of triangle ABC is equal to B1 by B. I am taking the same property and writing three equations. What are the equations? Square root of area of triangle T1 by square root of area of triangle ABC is equal to B1 by B. Like second, square root of area of triangle T2 by square root of area of triangle ABC is equal to B2 by B. Square root of area of triangle T3 by square root of area of triangle ABC is equal to B3 by B. Now add all this. Okay. When you add all this, now when you see the left hand side part, area of triangle ABC, area of triangle ABC, area of triangle, the denominator is area of triangle ABC. So when you take LCM, denominator will be square root of area of triangle ABC. And what is T1? Area is given 4, so root 4, 2. T2, root 9, it is 3. T3, 16, 4 is equal to B1 by B, B2 by B, B3 by B, sum of these. Again here the B is a common denominator. So B1 plus B2 plus B3. Okay. So what is B1 plus B2 plus B3? So it is B. What is 2 plus 3 plus 4? 9. 9 by square root of triangle, area of triangle ABC is equal to B1 plus B2 plus B is B by B. B and B get cancelled, it is 1. So 9 equal to square root of area of triangle ABC, then squaring on both sides, 81 is equal to area of triangle ABC. Okay. So like you can find the area of triangle ABC. When, if you doesn't know the process proper. If you know the process, if you are able to identify area of triangle T1, area of triangle T, those are similar, simply take that root 4 plus root 9 plus root 16 whole square, which is nothing but 2 plus 3 plus 4, which is 9, 9 square 81. You will get answer by only one step. That's the difference between having the concept without having the concept. That's the most important. Okay, now I will maybe you understand, but do not feel that every question in the same mode. So, they are. So, very important is in the chapter is application of geometry with algebra. So, I will take one question which is already given in the examination. So, let us see that question, very simple. Once the question was given in the examination also, I think so. So, means the same question will not comes in the examination, but the same kind of property will comes in the exam. See it. Okay. All are right angles here, and they name it as this one is AB, this one is CD, and this one is PQ. Of course, the length of that is this is x, this is y, and this is z. Then you have to prove that 1 by z is equal to 1 by x plus 1 by y. So, this is the most important. Okay. Now, how you are going to prove this statement? So, can you say how you are going to prove this? So, maybe in the textbook, in books, it is given more number of steps. 2 steps is enough to get the answer. Okay, now I'm considering the triangle BDC, this triangle. Okay, so what you consider here? BDC, and this angle is 90 degrees and this angle is 90 degrees. These two lines are. So, here when you take these two lines, this is a transversal. The corresponding angles are equal, means those are parallel. When these two lines are parallel, means you can say PQ is parallel to CD. So, just now take the basic proportionality theorem. What is the basic proportionality theorem? The line which is drawn parallel to the one side divides the remaining two sides in proportion. So, we can say simply, or you can say for example, this Z by Y I am taking, Z by Y, this by this. So, when you consider triangle BZQ, this one, so BQP, this triangle. When you consider this triangle, when you consider the whole triangle, then these two triangles are similar. So, when they are similar, so these are the corresponding sides. So, now you can say simply BQ, this side, by BD, BQ by BD is equal to Z by Y, correct? Because they are corresponding, they are in proportion. Say equation 1. Now, I am considering the triangle ABD, this ABD, this triangle. When you consider this triangle, so it is again, when you consider PQD, this, and the ABD, these two are similar triangles, am I correct? When these two are similar triangles, you can say Z by X, Z by X, this is a very important. So, previously you can say Z by Y, sorry, Q, this is a Z by Y, this is a simply you can say QD by BD, QD by BD is number 2, correct? Okay, QD by, this is a QD, and first one, see this is a triangle, correct, and this is another triangle, of course inside the triangle. This triangle is similar to the whole triangle. These two are corresponding sides, and this and the whole is corresponding sides. So, QD by DB, of course BD is equal to PQ by AB, of course Z by X is equal to QD by BD. Now, just add 1 and 2. When you add 1 and 2, you will get the answer. So, Z by Y plus Z by X is equal to BQ by BD plus QD by BD. It is very clear, when you take it as a very clear, BD is a common, so LCM is BD. So, BQ plus QD will come, correct? What is BQ plus QD, which is BD? So, BD by BD, which is gives 1, means Z by Y, Z by X. You can take Z common from these two, that is 1 by y plus 1 by x is equal to 1 or 1 by y plus 1 by x is equal to, send z to the other side, which gives the 1 by y plus 1 by x equal to 1 by z. It's over. Clear? This is the most important. I understand. So, see, the clarity is very important. The perceptual levels is very important. How you perceive the concept. So, some of you may write maximum number of steps, and in the examination there is a myth in the minds of the teachers especially. So, if you write more number of steps, then we will get a maximum number of marks. It is wrong. The procedure will be given marks. How many steps you have written, it is not the criteria. So, you have to write the answer, that is the most important, maybe 1 step, maybe 2 steps, maybe 3 steps. So, that is very important. I did in 4 pages, so I get 4 marks, it is not the correct criteria. Okay, now we will see one more question, a very important question of course. Shall I take one example already, which is given in the textbook, okay, based on these things. Okay. Coming to the next one based on algebra. So, here one triangle is given, the triangle is A, B, C, of course, this is D, E. Okay. And here simply the values are given. AD is equal to this one 8x plus 9, and CD is given as x plus 3, and BE is given 3x plus 4, and CE is given as x. Okay, and it is given a DE is parallel to this AB. DE is parallel to AB, then find xy. Okay, find the xy. This is a very important. Okay, then how to do it? This is the most important. Now see, very simple. You can say AD by DC is equal to BE by CE, or simply CD by DA is equal to CE by AB, correct? It is a basic proportionality, simply it is a basic proportionality theorem. Now you can apply the values. CD is x plus 3 by DA is 8x plus 9 is equal to x by 3x plus 4. Take the cross multiplication. So, x plus 3 of 3x plus 4 is equal to how much? X of 8x plus 9. Now, you can say this is 3x square, correct, plus 9x plus 4x, 13x plus 12 equal to 8x square plus 9x. So, send that other side, maybe it is 5x square, 13x and minus 4x, okay, minus 12 equal to 0. So, 5x square minus 4x minus 12 equal to 0. So, it is a simply a quadratic equation, correct. You have to solve it. Or you know how to solve the quadratic equations? So, 12 5 is 60. Okay, you have to divide this into 2 values. When you take the product, it gives us 60. When you take the product, the sum, it will be minus 4. So, 60 means 10 6 60, correct, product gives 60. Take one of them is minus 10 plus 6. Now see it, minus 10 6 60, minus 60, correct. Minus 10 plus 6 is minus 4. So, you will get it. Now, you have to solve it. 5x square minus 4x minus 12 equal to 0. So, now you can write it as a 5x square, okay, and this is minus 10x plus 6x minus 12 equal to 0. So, simply, so we can say 5x square minus 10x plus 6x minus 12 equal to 0. Take 5x common here, x minus 2. Take 6 common here, x minus 2. Then x minus 2 of 5x plus 6 is equal to 0, a simple linear expression. So, when product of 2 simple linear is 0, then each one will be 0, that is x minus 2 is 0, 5x plus 6 equal to 0, then x is equal to 2 and 5x is equal to minus 6 or x equal to minus 6 by 5. What is x here is nothing but the length of the line segment. So, minus is not possible. So, x is equal to 2 like the question comes in the examination. So, you have to practice all these in the examination. This is the most important. So, sometimes the question may be asked like okay. So, reasoning questions. So, reasoning questions is a very important. Okay, reasoning questions are, for example, the reasoning question is given as in a right angle triangle ABC. Okay, the smallest side is the very smallest side is for example, the very smallest side is equal to as you like it as 17. The smallest side is 17. Then find the perimeter of the triangle. Find the perimeter of the triangle. This is the question. Here the very important is remaining sides are integers. Remaining sides are integers. Okay. So, when this question is given, maximum children and some of the people also will do a mistake. Okay. So, why I said this mistake means that they will search for the Pythagorean triplet which is concerned with the 17, they will search it and they are trying to get the answer here. Okay. So, but it is not the way. What is the given information in right angle triangle? The smallest side, it is a smaller one. So, you know that the biggest side or the longest side in the right angle triangle is hypotenuse, correct? So, it will not be 17. So, it will be either this or this 17. Which one you are going to say it is 17? So, for example, say it is 17 and we does not know the remaining, say it is m and this is n. Then what is the relation between these three? You know that by using Pythagoras theorem you can say m square is equal to n square plus 17 square, correct? The square of the hypotenuse is equal to sum of the squares of the remaining two sides. So, m square equal to n square plus 17 square, or you can say m square minus n square equal to 17 square. M square minus n square equal to 17 square. Is it clear? What is m square minus n square? You can say either m plus n or m minus n equal to 17 square. So, maybe everyone will get the steps up to this. So, I think so no one will make a mistake. So, here only the next step is a very important. If the children knows how to do it, you will get the answer, otherwise it is a very difficult to get the answer. Very simple, but you have to think logically. The very important concept is 17 is a prime number. 17 is a prime number. It has no factors other than 1 and 17 itself, correct? So, m plus n of m minus n has two possibilities, maybe 17 square of 1, 281, 289 of 1, one possibility of product as a factors, other one is 17 of 17, am I correct? There is no other possibilities. And here you know that m and n are the sides of the right triangle. When the sides of the right triangle, it is very clear those are non-zero integers. When those are non-zero integers, very clear m plus n is more than m minus n, and m plus n never equal to m minus n, that is not possible. When you consider 17 of 17 means here m plus n should be 17, m minus n also 17, when it is possible when n equal to 0. When n equal to 0, is it possible to represent it with one side? So, means one, there is no side, means a triangle is formed by 3 line segment, but not by 2 line segment. So, there should be a third one, means when the triangle formed, n has its a specific length more than 0, am I correct? So, this is not possible. When it is not possible, then you can say m plus n of m minus 1 17 square of 1, it is very clear m plus n is more than m minus n. When m plus n is more than m minus n, then you can say m plus n is equal to 17 square. Then what is required here? Perimeter. perimeter equivalent. What is perimeter here? Simply the sum of 3 sides. This is the triangle, you know. This is 17. So, we sum of 3 sides. This is 17. You know the m, and this is n. M plus n value, you know that is 17 square, and the other side is 17. You can say 17 square plus 17. You know that 17 square is 289, and plus 17. Simply it is a 306. So, the perimeter of the right triangle is 306. So, this is the most important. See the logic. This is a very, like we have excellent questions in the similar triangle chapter. So, tomorrow we will continue the similar triangle properties and including other concepts, how the this basic proportionality is concerned with the other parts of the things, and we will discuss the how to construct a similar triangle to the given triangle. These things we will discuss it tomorrow. So, thank you for listening. Have a nice day.